Hello, curious mind. Have you ever paired your phone with a speaker and wondered how it was able to connect, or how your smartwatch syncs your steps or your car knows you're near? It's not magic, it's Bluetooth. But today we're going way deeper than just short-range wireless. We're going under the shell, inside the signals, into the actual system. Well, welcome to the magical world of Bluetooth, the invisible connection between devices. But today, we're not just going to say it connects wirelessly. We're diving into the science, the signal, the pairing dance, the invisible force, and why your AirPods don't start talking to your neighbor's TV. Welcome to How Things Works. And if you're just seeing us for the first time, this is the channel that breaks down technology into bite-sized explanations about the world around you. Kindly hit the subscribe button and turn on the notification bell so you'll be the first to know when we post another smart breakdown of the world around you. Let's get started. Part 1. What is Bluetooth? Bluetooth is a type of short-range wireless communication technology. But unlike Wi-Fi, which sends data over longer distances, Bluetooth is all about close-range convenience. It's built for low power, small files, and steady continuous communication between devices like phones, smartwatches, headphones, speakers, and even your car stereo. Bluetooth starts as hardware. Yes, a real physical chip. Tiny, usually no bigger than your fingernail. You'll find it soldered right onto the motherboard of your phone, speaker, laptop, even your fan remote these days. This chip has one job: convert electricity into radio signals and vice versa. That's how data like music, files, or even your voice can fly invisibly from device to device. And guess what? Bluetooth is just a tiny radio transmitter and receiver. It's like a walkie-talkie, but with way more manners. It uses radio waves, just like FM radio, but it operates at 2.4 gigahertz, a frequency that's globally available for unlicensed devices. That means almost any gadget anywhere in the world can use it. No SIM, no password, no monthly bill. Imagine you're whispering secrets at a loud party. Instead of shouting in one spot, you jump between 79 different rooms hundreds of times per second. That's what Bluetooth does. It hops frequencies 1,600 times per second to avoid noise and interference. This makes it surprisingly stable, even in busy environments with Wi-Fi, microwaves, or other devices. Part 2. How pairing works. Now, how does your phone find your speaker? Every Bluetooth device, your phone, your speaker, your earbuds, has a unique address, kind of like a fingerprint. It's called a BD, a DR, or Bluetooth device address. And here's what it looks like: 1234, 56, 78, 91, 10. It's made up of 6 groups of numbers, and each group is 1 byte or 8 bits. That means this whole address is 48 bits long, but we can break it down even more. The first 2 groups, 1234, are called the NAP. That stands for non-significant address part, but don't let the name fool you. It's still important. It's used in organizing and routing. Next is 56, the UAP or upper address part. It's just 1 byte, and it sits right in the middle. This byte helps with things like authentication and clock offsets. Then you have the last 3 groups, 78, 91, 10, called the LAP or lower address part. This section plays a big role in identifying the device during communication. Here's something even cooler. The first 3 bytes, 12, 34, 56, are known as the OUI, which stands for Organizationally Unique Identifier. This tells you which company made the Bluetooth chip. For example, Apple might have its own OUI. Samsung might have another. Even unknown brands have registered OUIs. You can actually look up an OUI online to find out what company made the Bluetooth module in your device. When you pair them, the devices create a signature. Basically, they agree on who they are, what they can do, and how to talk. This pairing is saved, so next time it connects almost instantly. Unless you are that guy with 23 paired devices, then good luck. Let's say you hit play on a song. The phone turns that audio into binary data, ones and zeros. The Bluetooth chip turns those ones and zeros into radio wave pulses. These pulses fly through the air, and on the other side, your speaker's Bluetooth chip catches them, decodes the signal, and plays the sound through its amplifier and speaker coil. All this happens in real time, thousands of bits per second. Bluetooth is low power by design. That's why you can wear earbuds for hours or keep your smartwatch connected all day. But low power means short range, usually around 10 meters. Class 1 Bluetooth chips can go farther, up to 100 meters, but they're rare and use more juice. Now, what about when you walk away? Bluetooth isn't just blasting signals blindly, it checks for connection status. If you move out of range, it drops the connection to save power, and if you reconnect, it resumes without asking. Also, some devices have smart detection. If your earbuds go back in the case, Bluetooth shuts off. Or if your phone battery's low, it may reduce Bluetooth power automatically. Part 3. Security and limitations. But wait, if it's wireless, can people hack it? Not easily. Bluetooth uses encryption when sending data. That means your information is scrambled like a digital lock. Even if someone intercepted the radio wave, they'd need the key to understand it. Still, don't pair your phone with sketchy devices, just like you wouldn't connect your charger to a brick in an alley. Bluetooth isn't perfect. It's slower than Wi-Fi. It can glitch in crowded areas. It can only talk to a limited number of devices at once. But for small, personal, wireless tasks, it's nearly unbeatable. So next time you connect your wireless mouse or blast music from across the room, just remember, you're using electricity, silicon chips, radio waves, encryption, frequency hopping, and smart handshake protocols, all packed into one chip smaller than your fingernail. That's Bluetooth. That's how it really works. Stick around, because next time, we're breaking down something even cooler. If you enjoyed this breakdown, leave a like, drop a comment, and let us know. Which system should we break down next? This is How Things Works, and we'll see you in the next one.